Before we start, look at this picture in the slide with a ladybug in a maze trying to reach a sun. I bet you've already found at least one way for this ladybug to escape. But how could you manage to do that? Probably you started at the beginning, moved to the left or right. Maybe you hit a border with no exit and turned around or started again from the beginning. While I'm talking, you probably found not only one way for this ladybug to escape, but which one is the best or the shortest? Well, you just made an algorithm in your mind. In computer science, an algorithm is a set of steps used to complete a specific task. There are building blocks for programming, and they allow things like computers, smartphones, or websites to function and make decisions. But a lot of things we do in daily life activities are also similar to algorithms, like baking cake with following the recipe or driving a car from home to university. There are many ways to do specific tasks using different statements and different orders and achieve exactly the same result. But some algorithms are better than others, even if they produce equal results. Every algorithm has 5 main characteristics: input, output, definiteness, finiteness, and effectiveness. In every algorithm, a range of inputs should be specified. It may contain 0 inputs, but that should be declared in advance. Let's go back to our ladybug and the maze. What inputs could be defined here? You can split the maze in blocks and express these blocks as ones if it is wall, or zeros if it is a possible path for your ladybug. Then the input for the algorithm is a matrix of zeros and ones. Depending on what is your goal, the algorithm should have at least one or more outputs. Otherwise, there is no use of writing an algorithm. It may not return any value, but it definitely does something in your program. In our case, the output can be an estimated path for the ladybug to escape, or Boolean value if she escaped or not in a certain number of steps. Also, an algorithm should be clear and precise and must lead to only one meaning. For example, if your defined step size is equal to square root of -1, you don't know what size it is and how to initiate a ladybug step, so your algorithm won't know how to perform either. Finiteness is also important because an algorithm must determine it after a finite number of steps. Even if your maze has no exit, the program must stop eventually. Finally, effectiveness means that every instruction must be basic enough to be carried out by any programming code in any language, even by writing on paper. Now then you learn basic characteristics, we can discuss what are the main types of algorithm. The algorithms can be classified into different groups. Each algorithm has a goal, but the number of goals is infinite, and they usually assigned by different kind of groups. An algorithm may be implemented according to different principles and structures. The main categories are recursive or iterative, logical or procedural, serial or parallel, deterministic or non-deterministic, and others. The most popular classification is by design method. There are categories like divide and conquer, dynamic programming, linear programming, reduction using graphs, the probabilistic or heuristic methods. Of course, it is worth to mention classification by complexity, constant, linear, logarithmic, cubic, and others. There are many other possible algorithms classifications, like classification by research area or branch and bound enumeration. In this lecture, I would also like to show some additional examples for your better understanding what is an algorithm, how it works, how they differ from each other, and for what purposes they can be designed. Recursive algorithm is a way of solving a problem by having a function that calls itself. One of the most popular examples is estimating factorials. Then the same factorial function is recursively called over and over again until it reaches the value of 1. divide and conquer algorithm, then a given problem is fragmented into smaller subproblems, and the subproblem is then partially solved. The algorithm is recursively used over several parts and determined then the further subdivision cannot be performed. This is a very popular type of algorithm in solving sorting problems. For example, merge sort, that splits the array into two halves or more and sorts every part separately. I won't stay at this problem explaining how it actually works, because sorting algorithms is a wide and interesting topic that deserves a separate lecture in this course. One of heuristic algorithms is greedy method, that works on a principle that an immediately available best solution at each step must be chosen without worrying about the effect on subsequent steps. The most popular example is about a very smart programmer who has infinite supply of 50, 20, and 5 coins. He wants to buy a lunch that costs 80 coins in a minimum number of coins. Just to pay for the lunch, he could give the money in different ways. For the minimum number of coins, he has to use greedy algorithm. At each iteration, add coin of the largest value that don't exceed the total cost. He starts with a coin of 50, then takes 20, and finally 2 coins of 5. All the other ways to pay would lead to a higher number of coins. Backtracking algorithms are when all possible solutions are examined by moving back and forth until the solution is found. Here we can go back to our ladybug and the maze. Every time we hit a wall with no entry, we go back and try other possible solution until the exit is found. This is only a few examples, but humans and computers use algorithms to perform everyday tasks. The difference is that computers can use algorithms and calculate things better, faster, and more efficiently than we can. Algorithms are everywhere, and modern world would not be possible without them. We touched only a few aspects in the algorithmic world, but essential part in being a computer scientist is applying an existing algorithm and writing a new one when needed. That's all I wanted to show in this lecture. Thank you for your attention.